Okay, I've had you working in your groups and see what you've come up with. What's an array? What's a way we could do a square array to make the number 4? Somebody could put that up here. That's right. It's just a 2 by 2 array. It's in the form of a square and it comprises smaller squares. How about 16? Somebody could do that one. Okay. Yep, that's a 4 by 4. 4 times 4 gives us 16. That's how we represent perfect squares. What about the 49? Anybody get that one to work? Okay, so you're putting down 7 rows and 7 columns. 7 times 7 is 49. Who got -1 to work? Who did that one? What times itself equals -1? Anyone? Yeah. Okay. What'd you find out? Can't do that one. Now, if this was a positive one, it would be very simple. 1 times 1 is positive 1. But a -1, there's no way to take a -1 times itself and get another negative. It can't be done. At least it cannot be done within the realm of what we call real numbers. It can, however, be done within the realm of imaginary numbers. So yes, we do have imaginary numbers. And the square root of a -1 is equal to I. It doesn't exist in real numbers, it exists in imaginary numbers. So I is on my t-shirt here. We have Pi and I having a conversation. And I is telling Pi that Pi needs to be rational, because of course Pi is an irrational number. And Pi is telling I needs to get real, because I is not a real number, it's imaginary. So we still can work with them mathematically. The square root of -4, remember if you break down a larger perfect square, you can break it into the multiplication of 2 other perfect squares. So the square root of 4, and the square root of -1, the square root of 4 is 2. The square root of -1 is I, so that would be 2I. So I'd like you to work on this one now. You have 8 minus the square root of 9. So which group can let us know what that is? Okay, so we have 8 minus a -9, so I'm focusing on this part right now. I can bring down the 8. Now the -9 can become the square root of positive 9 times the square root of -1. The square root of positive 9, you can do that one. It's just 3. And the square root of -1 is equal to I. So that is how we express this. We call this a complex number. A complex number has a real part, and that would be just the number 8, and this is the imaginary part. Now, when we're dealing with plain algebra, usually what you will do is express the 2x, the part with the variable first, and then the part that's not a variable, the constant. When we talk about imaginary number, complex numbers, traditionally the real part comes first, followed by the imaginary part. So I would like you to work with that now. Work with this 8 minus 3I, and see if you can add it to another 4 plus 10I. Add these two complex numbers together, and then I'll give you a bonus problem. So which in your groups can figure out those? Okay, so when we add units with x or n or some other variable, notice that we can't add the 2x plus 7 and get 9, or the 2x plus 7 and get 9x. We have to add apples with apples. So let's add 8 plus we can't do 8 and 3i, we can't do anything with that. Can we do it with something else here? Can't add 8 and 10i. We can add 8 and 4. So that's an addition. So the 8 plus the 4 becomes 12. What about the I terms? We have a negative 3i plus a positive 10i, and that added up will give us 7i. And that's the only way to express that, or it's the preferred way to express that, but we cannot reduce this, we cannot combine, we cannot do anything else with that. What happens with the subtraction? We have 9 minus 6, minus 6, that gives us 3, and then with the i's, be careful now, 2i minus a negative 3i. When we subtract a negative, it's like adding a positive. So you switch both words around. 2i minus a negative 3i will give you positive 5i. And that is the way you express that. So that is how we add and subtract complex numbers. Tomorrow we're going to get into multiplying and dividing complex numbers. And you'll see that there are some neat little cancellations that take place.